All right, so this is your homework, your latest homework, by the way. Your latest homework is actually, it's PDF based, yes, which is not on the exam, right? PDFs and Word documents are not on the exam. This will be. Sorry, this won't be either. The Excel sheet will be, as you've seen. But this is a fun exam because it's actually a bit of a security problem instead. So the idea here is that we've got a PDF. So I actually have a zip file full of some ebooks that I encrypted at one point, so that basically I could store it on my public, web browser without violating copyright law, because it was there available for the public, but only I had the key to decrypt it so I could get it any time, rather than putting it behind a password protected web page. And of course, I forgot the password, right? So now if you forget the password for a PDF, you can try, banging it in. It doesn't really ever lock you out from a PDF. So that's a big thing with, if you can't, like here, in my, in this, right, if I do sudo, which means so if I do sudo, and this does make me the super user. If I type in my password a bunch of times, right, so first off, it adds in a delay to keep me from basically going through it very quickly. And if I do it 3 times, it says incorrect password attempts, and it kicks me out, right? And there's actually, at some point, like, a lot of times it will also say this incident will be reported, which it will you can set it up so the administrator gets a message or something, right? Because that's kind of important. You don't want to be and your phone, there's probably a security setting in there that basically, if you hit 20 attempts on the password, it resets the phone or something like that, right? 20 bad password attempts in a row. Pro tip: if you have a kid, don't enable the setting. So, not speaking from experience there, that was a preventative measure on my part. So, but PDFs fortunately have no such restrictions. We can attempt to put in a password as many times. So, you can't remember the password, but you do remember it was a single English word. So, it was a single English word. So, trying to guess your forgotten password is actually kind of boring. So let's create an automated process that does that. So there's a dictionary.txt file. It has 44,000 English words with 1 per line. So basically, open the file, throw each of those words at the decrypt function, right, which will return 1 when it gets decrypt, when you find the right password, right? So you pass each word into the list of decrypt. If it returns 0, the password was wrong, and you should try the next password. If it returns 1, you should break out of the loop using the break statement and print out the hacked password. Right? This is what what's often called hacking, even though it's just it's more cracking, and it's a brute force cracking of a password. So it takes a couple minutes to do this.
How would you define hacking?
Hacking is tinkering. Hacking is just the computer terminology for being a tinker, being willing to mess with stuff and mess with settings and mess with your own system and experiment.
And what do you call what
cracking?
Popularizes just cracking.
That's cracking.
Hacking and cracking.
Yep, cracking. But unfortunately, that's just simply it's like a scientist arguing that basically everybody's using the word theory wrong. So, it's there's the popular usage, and people understand. They grok what you mean. So this is essentially a brute force password breaker. Now here we're using 4,400 English words rather than saying. So the other way to do it, if you're trying to if it's like a random hitting all lowercase characters, is that you literally, try all possible combinations of length 1, then all possible combinations of length 2. So 26, then 6 times 26, then 26 cubed, then 26 to the 4th possible combinations. But these basic words don't take too long. However, right, you know, if I'm using a password that's simple, that uses only lowercase characters, right? A password of that length is, if I'm just using lowercase characters, well, let's assume I'm using uppercase and lowercase characters. So that's 52 different characters. And if I'm using 15 characters, or let's say 16 characters, then that's how many possible passwords there are. That's a lot of passwords. Let's go ahead and say you can do 1 per second, right? So we'll just go ahead and divide by 60. There. That's how many I can do in a minute. So that's how, and then 60 times 60, that's how many I can do in an hour. There's 24 hours in a day, so that's how many I can do in a day. And there's 365 days per year, so that's how many I can do in a year. And that's how many I can do in a, and that's how many passwords I can do in millennia. So, sorry, that's so that's assuming I can do 1 per second. If I can do maybe 10,000 a second, or even 1,000,000 a second, if I can do 1,000,000 passwords a second, that's still a lot of second. Sorry. Well, that's how many millennia it's still going to take me. Right? Right, so if I can multiprocess this, and like I can use, let's say we want to use, so I had 1,000,000, so let's say I can do 1,000,000 a second in a multiprocessing, then maybe I can get these up to 1 billion, or maybe 1 trillion, right? I'm still looking at a lot of millennia to crack a very long password. A very long passwords are very hard to break, which is why you go for the easy small passwords. Every possible 52 character combination. And I'm probably using words that. And now, yeah, there are weaknesses. That's just doing brute force, and that's just a back of the envelope thing that probably has a math error in there somewhere. All right, so that's your next homework assignment.